Hello, TSB students. I am going to be playing I Got Rhythm from An American in Paris and Girl Crazy. It's a Gershwin melody. And then I will do our Wonder of the Day. So, our wonder of the day is what music is in your DNA? Science and technology move at a fast pace. One area that's growing very quickly is genetics. Modern researchers have learned a lot about human genes. They found that genes help shape who people are and how they behave. They can even influence what illnesses people have. Does DNA decide people's interests? How about their special talents? Think about music. Are musicians born with music in their DNA? Is a love of music built into people's genes? DNA may or may not shape a person's love for music, but some experts are using music to study DNA. How is that possible? Let's take a deeper look at this new way of learning about DNA. Your DNA is like a recipe book. It holds the instructions for making all the proteins needed for your body to function. Each protein is made of amino acids. There are 20 different amino acids. One protein could have as few as a dozen or as many as thousands of them. When scientists study proteins in detail, they write the amino acid sequences as a series of text letters. Sometimes these series contain thousands of letters. This makes it hard to compare proteins. It also makes it difficult to notice their patterns. Some scientists have found a way to make it easier. They use a process called sonification. They assign a musical note to each value of the amino acids in the sequences. The result? Protein songs. So-called protein music lets scientists use their ears to study amino acid sequences. What was difficult to see with the eyes can often be more easily heard with the ear. Scientists can make more than one song for each protein. For example, they might assign different notes based on certain properties, such as solubility or charge. This lets scientists study proteins more closely than ever before. Protein music holds exciting possibilities for research. It allows scientists to compare different proteins with greater ease. In some cases, they use protein music to compare the proteins that appear in both humans and other animals. Isn't that interesting? Experts can use music to learn about the similarities and differences between the DNA of humans and other living things. What would your DNA sound like? Would you like to compare your own protein music to a friend's someday? Maybe music is in your genes after all. Here are some things that you can try out. Have you ever heard protein music? Jump online to explore or listen to the music of proteins folding online. You'll learn more about how scientists are using protein music to create melodies that map how proteins function. You can also listen to an audio sample. What do you think about using music to represent complicated data? Do you think it helps? Why or why not? To dive deeper into how scientists turn protein sequences into music, Check out A Protein Primer, a musical introduction to protein structure online. Do you think you would enjoy turning protein structures into music one day? Could this type of research be the perfect job for someone interested in both science and music? Turning large batches of data into music for easier analysis shows great promise in the area of DNA research. What other areas might benefit from such an approach? Can you think of any other research areas that involve huge amounts of data that might be easier to research if it was converted to music? Brainstorm a bit to see if you can come up with any other areas where converting data to music could be beneficial. Share your ideas with a friend or family member. See you next time.